Hey everybody, John Grimsmo here, and I made something really cool over the weekend. It was actually my birthday on Saturday, and really all I wanted for my birthday was to come into work and have the shop to myself and make this thing, which was really, really fun to make. Got to make it on our Willemin machine. Check this out. So this is for Saga Saturday, and this is a Saga checking fixture. If I can get it to focus, we're getting a new camera soon. It'll focus better. So this is a piece of brass, 1-inch diameter brass, with a lot of precision features, and these are 0.065 gauge pins that allow us to basically over-constrain this part in a weird way. So this right here is our threaded sleeve for the Saga. Very critical component that is what holds all the magic. All the 3 ceramic ball bearings that are inside that make this happen are held on with this threaded sleeve. And it's always been a challenge to measure the 3 holes to the taper on the inside where the button fully seats. And it's a very critical dimension, and it's been tricky to measure. So I've had this idea. I literally bought the pins over a year ago, and I've been wanting to make this. I've had the idea in my head for the longest time. Relatively straightforward, just made on a lathe. I made it on the Willemin. The B-axis came down and milled all this stuff away so that it's nice and flat, and then I drilled a .059 drill bit and then an 065 reamer, and then I have these 065 gauge pins that just go in super nice. And what they do is, because there's 3 of them, you're kind of forcing an over-constrained state on this threaded sleeve, but let's see if I can line this up. There you go. So that's with 1 pin in place, and I can kind of wiggle it around, get it to go through. There you go. 2 pins. So now all 3 pins are in. And then if we back them out ever so slightly, I can have a reference button. Now this button, the way we make this button is I'll take one of my pins, turning tool, how do I hold this? The turning tool comes in, turns the face, turns the OD, and then it turns the taper up and then turns this diameter. And this particular one measures exactly 0.28000 on this OD, or 2800 on the OD, which kind of lets me assume that the taper is accurate to the turn diameter, and it's like, it's a reference pin. The taper is as accurate as I need it to be. So then if I put my 3 pins in, and I hold this threaded sleeve in there by the 3 pins, and I put in my reference button. Now I have the threaded sleeve is constrained by the 3 pins, and this reference button gives me kind of a perfect taper to top face reference. And as long as I use the same button for every check and the same gauge for every check, and all I'm replacing is the threaded sleeve itself, then we can have a comparative measurement. It's not necessarily an absolute measurement, it's a relative measurement, measuring from our standard to the next. So it's nominal, 0 is kind of irrelevant, and all this goes together with how the button feels, and if there's any bounce at the bottom of the button travel, or if the threaded or the slider is not able to go fully up and capture the taper and get those balls over the taper hump. And yeah, so I think this gauge will allow us to measure way more accurately than we've ever been able to measure before in a comparative fashion. And so far, I've been testing it. I got my little post-it note here with my little string of soldiers where I'm measuring each one and seeing a difference. And I've got 2 baggies, which I'm assuming were made on different production dates or different production batches or something. And there is a slight difference. not only part to part, but also kind of batch to batch. And I think it's really fascinating. Here, we have the assembly put together, and I have my gauge zeroed out. And honestly, there is a bit of a taper across the top face of the part, going left to right, side to side, which I don't like, but there's a lot of variables that could cause that out of flatness. I'm not going to worry about it too much. Basically, I've decided to measure on center of this button, which gives me a consistent reference point. And this one happens to be about plus 2/10 of an inch. And it's relatively repeatable. Finding that 0, 0 center of the thing is the kind of variable, but I'm not really shooting to split tenths here. I'm more looking for a comparative measurement. Okay, so that one is 2/10 plus 2/10. If I pull the pins out ever so slightly, pull my threaded sleeve out, button out. So then if I get a different one, so I assembled that one, get it under the gauge here, I'm seeing plus 6, plus 7, 7/10. Now, is that enough of a difference to notice a feel in the way? Is it to impart a bounce? I'm not exactly sure yet, because I've never measured this exact feature before. We've had some different ways to measure it with the optical comparator, the shadow graph, but this I think is significantly more repeatable, except for that taper. That really bugs me. But like I said, if I go to center line, I get a pretty repeatable, within a tenth, you know, wiggle room error, user error kind of room. So, okay, let's try one more. That was plus 7/10. Put this in. You kind of have to align it, loosely align it so that it will go in the first hole. Okay, put them all in. Let's try this one. Ooh, this one is negative. Negative 1 thou, maybe 3/10, 4/10. Big difference. Big difference. So now, what's really interesting, so now I've done maybe 10 parts and I have a range. I have a minimum and I have a maximum of this small sample size. So I'm going to assemble the minimum, I'm going to assemble the maximum, ideally with consistent parts, like the same button every time. And the balls are always the same size. And then I'll see if I feel a difference. If so, super win. Because this part is made in 2 separate operations, like the main side and the 3 holes are made on the main spindle, and then the part transfers to the sub spindle, and then a whole different set of tools and a different setup and a different clamping does the sub side. There's no reference between them. The operator, the machinist, Pierre, has to know how to measure this, how to offset the tools so that he can get a precision, you know, repeatable part. And like I said, he's had a method on the optical comparator, but I think this will be better. So, excellent. So I've picked 2 buttons that both mic exactly the same and also nominal diameter. And then I have 2 sliders that also, we have pin gauges that go on the inside that measure the ID, which also kind of assumes the taper as well. These 2 measure identical as well. So now I have consistent parts, the only variable being this threaded sleeve that is now measures on our checking fixture like significantly differently between the 2. Let's put them together and see what we get. All right, I have my 2 pens assembled with my 2 different mechanisms, A and B. A is minus 1 thou 3/10, B is plus 1 thou. So there's about a 2 thou total range, minus 1, plus 1 from whatever nominal I have. And I put them together, and my blue pen has a tiny bit more bounce, more wiggle than the copper pen, and I feel it. I still think we need to go more towards whatever I put in this pen. And it's not something you can hear, it's just kind of a feel thing. The problem is if you go, like there's a tiny bit of bounce right now, if you go make the tolerances so much different that there's no bounce, it's pretty fine line to go too far to where if you go way too far, then the slider doesn't actually fully go up and the pen can like fail when you're writing, which is not good. So if I like half load this thing so it's not fully seated, then it can fail when you're writing. But when we do it right, which is always, because we're perfect, we don't ship a bad product, basically. I would prefer there to be a tiny bit of bounce than to have a pen that could ever fail. But I'm trying to fine tune into that like minuscule fine line of perfection where it's just always at the bleeding edge of tightness. And I think this, I'm not there yet, but this gauge will help me achieve that goal, which is super duper cool. Yep, I think it works. I think it works well. All right, guys, I gotta go. Thanks for watching. Bye.